and the labor movement was ruined for decades because of this.
Okay, so the Industrial Revolution was dependent on two things. First, iron, and second was textile mills and the steam engine. And the Industrial Revolution improved transportation, communication, and banking. It also increased the volume of goods and the quality of the goods. But the living conditions and working conditions were bad for the working and poor. Armed trade allowed Europe to dominate the Indian Ocean, and colonization granted Europe to global resources and foreign trade. The European market placed high tariffs on exported goods, as to only allow the West to produce manufactured goods. The Opium War and the Arrowhead War is an example of technologically advanced warfare. And World War I is the first industrial war against Germany, Hungary, and the Ottomans. There was a power vacuum after World War II. And eventually this allowed for the United States to rise above the British Empire.
Okay, so now we are going to talk about the third roadmap point, which is the impact on transportation. So to start off, how many of you have actually seen a light bulb box? I hope. Okay, who can read the light bulb box? Any volunteers to read if I walk over to you and give you the light bulb box? Sarah. Okay. So what does that say?
65 W.
And do you know what W stands for?
No.
Well, it is named after a famous scientist named James Watt. James Watt in 1775. Well, pretty much, what is the definition of a watt? Which will just show kind of, I guess, get a feel for his, prestige for his invention, which I will describe shortly. So, pretty much, James Watt himself, he was named after a unit that's measuring the rate at which energy is spent. 1 watt is a joule per second. A joule is a unit of energy. So, pretty much, that's how we measure with light bulbs and whatnot, and found in common appliances in the international unit system. But, in 1775, James Watt, once again, as I said in my other presentation, he did not invent the steam engine, he refined it. Pretty much, he made a relatively smaller steam engine, well, not that small, but pretty much it would kind of look like you'd have a slate of rock, or a platform, and then here you would have a large boiler, and where you put the coal at a furnace, and then an exhaust pipe. And pretty much what these large, it wasn't movable at all, it was really heavy and really large and kind of inconvenient to use. However, they were implemented in most mines in order to kind of, it was used to pump water out of the mines, but since it required a lot of coal, and they were in a coal mine, it was okay that they used these large bulky machines. So pretty much, the next part of the story starts in 1802. In 1802, a man named Richard Trevithick was hired by Samuel Humford, the owner of the Penny Darwin Company, which is a company for ironworks at the time. So pretty much they do mainly building components out of iron taken out of the mines. So pretty much he was hired to make out of a steam engine a hammer that was an automatic steam engine hammer. This steam engine hammer was to be implemented in the mines, so that's the reason why they hired him. However, he noticed a different problem and worked on his free time in a movable steam engine. So pretty much, or the first locomotive. So pretty much these movable steam engines kind of look like this. Magical light bulb box. So this one is the first one, a model of the first one, called the Penny Darwin, named after the company. So pretty much, after he made his invention, he like as shown in the picture, there's the actual. They still kept the locomotive, and they are several models in museums of this locomotive. So pretty much what they did was like he patented it in 1803, and it was purchased by the Penny Darren Company in later in 1803. So it was quickly implemented for test runs. It made free journeys. The actual front part here was about 9 feet, and pretty much it could carry 10 tons of weight. And in its free test runs, it carried 10 tons of iron and 70 men along with it. 5 carts in the back, not including the coal cart to feed the fire. Pretty much, it traveled at 2.5 miles per hour, so it was relatively slow. And each of its trips took like about 10 hours, give or take, to travel like 10 miles. So it was pretty good for the time. And this was absolutely mind-blowing to people at the time. Because at the time, people would have to push the carts, or mules would have to push the carts. But they never ever had, this was the first time something that was not living was able to pull the carts. So they thought it was amazing. However, because this had a very large maximum weight capacity, they kind of began to exceed it, and it broke the rails, which is why Samuel Humphrey decided to kind of get rid of it. Now, in reality, Samuel Humphrey should have kept it because he could have become a millionaire, but, he said it would save him no money. So he got rid of the idea, after it destroyed a couple rails. So, pretty much, now the science time. Okay. So, pretty much, I'm going to explain how the steam engine works. So, pretty much, this is my dad's old model. He built it when he was little, but I'm pretty sure they still sell them. You can, take the coal out of it, and pretty much, there's a coal to feed the fire, which is the first part, which is, the opening would be right here. Inside this tank, there's a giant piston, and the piston will move this linkage right here, these 2 linkages. Pretty much, the 2 linkages would then in turn move a flywheel, which is pretty much converting linear motion into rotary motion. And then from there, a series of gears and cogs would turn the wheels and produce mechanical motion, or this moving forward. So here's how kind of it moves, like this. Except not that fast, but I'll pass it around so you guys can see. So don't break it, please. So pretty much one thing. So now that I have my model, so in this giant tank, I'm gonna show you what's going on, because that tank is actually a large piston, and so pretty much this is a general way the steam engine works. One second, just a minute. Yeah. So pretty much this is the general idea of how a steam engine works. This is a bit more of an advanced model that was used in the Penny Darren, or formerly known as triple tick locomotive. So pretty much we have, so in both diagrams, because there are 2 phases of motion, kind of, you can always see the steam under pressure is entering through the center pipe in either one. So pretty much, when the piston is forward, the steam is entering, and because of the way the linkage was moved, it is blocking the lefternmost exhaust pipe and access to the right exhaust pipe. So all this steam starts building pressure on this side of the piston. In turn, the piston moves back until we get our second phase, which pretty much the linkage shifts again so that it blocks the rightmost exhaust pipe along with access to the left. So the steam starts building pressure. So the steam starts building pressure on this side of the piston, moving it back. And pretty much you see the flywheel, which is attached to the cogs and whatnot. So yeah. Okay, so now I'm gonna start talking about first railroads. So pretty much, with the first railroad, like pretty much before the steam locomotive, the railroads actually did exist. But the thing is that the railroads like they were railroads because they were roads with rails. That's the thing. Like you would have pretty much like a railroad track, except you'd have a horse going on it, pulling the carriages along and carrying the people around and the goods around. So pretty much the horse, or in some even countries there was like men pulling the carriages for money. So but in Europe it was horse carriages. So pretty much in like around 1825, one sec. So pretty much in 1825, after Trevithick's invention, they started using the railroad for the specifically for, I think it was called the Darlington Stockton line, and it was the first time they actually got the idea to use locomotives, which was absolutely like people were flabbergasted. People were flabbergasted by the amazing force and how many passengers they could pull. And the thing is, this is the first time the locomotive was used for commercial reasons. So, yeah, the actual engine itself was remodified to be able to pull a lot more. And pretty much the name of the thing was I believe it was built by George Stephenson, and it was named the Rocket. And it can travel at 60 miles per hour, pull 7 carts full of people. So pretty much this became the new method of transportation because it was faster, it was easier. People could move from
2 minutes left.
Okay, people could move from countryside to the city in a lot less time. So this is why the first railroad was really, really different. So the last part would be the transcontinental in the United States. Pretty much it is it is what it is. It's the first transcontinental railroad, which means it goes trans the continent. So pretty much transcontinental would go from around New York-ish to all the way to California. So it on the internet just said Eastern States, so I was like, okay. And pretty much, yeah, that's why it was revolutionary. And I believe it was at the promontory. It was released in the Golden Spike. It was a convention there, and there was it was a promontory summit, Utah, in 1869, I believe, because they started the construction of it in 1860s. And the only other thing aside from railroad that was really important about transportation at the time, which I'll mention briefly, were the steamships themselves. But it was, as Vicky and Chin emphasized on, it was really important during, in terms of military impact. So that's why I didn't get into it too much, because it was technically overlapping on their topic. But, because we all did portions of the research. So, pretty much, with the actual steam engines, I believe the first one was, in the 1825 as well, and it was called the Claremont, and it went all the way, and it traveled 100 miles and took 32 hours to go from New York City to Albany. And pretty much, yeah, that was the first steam engine ship trip. And I don't remember the name of the guy who made it, but it was the first time people put steam engine on a boat. So Robert Fulton, yes. So, oh yeah.
Wait, what?
Alright, we're at the conclusion.
So,
Done?
thank you. Because we just had our thesis at the beginning, so